In this lesson, you're going to learn how you can write direct variation equations. So let's review again what it means to be directly proportional or have direct variation. Remember, the constant ratio is called the constant of variation. In direct variation equation, the constant rate of change or the slope is assigned the special variable k. And the graph of a direct variation always passes through the origin, and it is also going to be a straight line. So how do I write direct variation equations? Well, let's start out with the y is equal to kx form. And I'm going to solve and get down to just the constant of variation, having the k on one side. And so to do that, I would be dividing both sides by x, because remember, what you do on one side, you have to do on the other. So I'd have y all over x is equal to k, and we saw this in the last lesson. Now another variation, or a form, that we hadn't looked at is, let's say that I have y is equal to kx. Well, another thing that I could do is I could solve by moving and having just the x on the one side, giving me the y all over k is equal to x. So those are the other forms that you could see the direct variation equations to be in. So let's go ahead and we're going to explore the direct variation equation a little bit further. Let's go ahead and see what happens if I have the 1, 2, 3, 4, 5. And we're going to take a look at the form y is equal to kx. So again, remember, in your input-output form, the input is the x and the output is the y. So if I had y is equal to, and let's give our constant of variation, let's say that it's going to be 3. So y is equal to 3 times 1. Well, then y is going to be 3. If we have y is equal to 3 times 2, then it's going to be 6. If y is equal to 3 times 3, we've got 9. We'd have 12, and we'd have 15. Okay, so let's take a look then at, remember what we had said in the last lesson about our ratio of y all over x is equal to k. Let's take a look at that. Let's take our y all over x, our 3 all over 1 is equal to 3. 6 all over 1 is, 6 all over 2 is equal to 3. 9 all over 3 is equal to 3. So see right here what we have is we've got that constant of variation. The 3 is the number that we're multiplying each one of these by, and by taking that ratio of y all over x, that is going to be equal to the k. Alright, so tell whether each equation represents direct variation, the form y is equal to kx. Well, in this first one, yeah, that does. Our constant of variation is the 4, and so, yes, this represents it. Let me just get my pen here. All right, y is equal to 4x minus 3. Let's take a look at what that is going to look like on a graph. So if I were to graph y is equal to 4x minus 3, I'd have my x, my y, and I would, let's just do 0, 1, and 2. Let's graph those points. So if I took 4 times 0, that's 0. 0 minus 3 is negative 3. If I took 4 times 1, that'd be 4. 4 minus 3 is 1. And then 4 times 2 is 8. 8 minus 3 is 5. All right, so on our coordinate grid, what this is going to look like. And let's remember back to what we had said in that last lesson about what direct variation looks like on a coordinate grid. Remember, we said that it goes through the origin. It goes through 0, 0. So I'm going to graph, and I'm going to go 0, negative 3, 1, 1, and I've got 2, up 5. All right, so let's draw our line. And notice how this does not go through the origin. It goes up at a constant rate. It's going to go up 4 each one of these. Our slope is 4. Remember, it's a change in the y all over the change in the x. So I went up 4 over 1, and I went up 4 over 1. Okay, except for I started at a negative 3. So therefore it never went through the origin. So this is not a direct, does not represent direct variation. It is not proportional. I also, if I were to take a look and find that ratio of the x all over y is equal to k, if you take a look here at my ratio, negative 3 all over 0, well, that is equal to k. Do I get that constant of variation? Do I get that 4 in that case? No. Same thing with my ratio of 1 all over 1 does not equal 4. So in this case, no, it is not. All right, y all over x is equal to 4. Well, let's start again and show how we've got y is equal to then, and our constant of variation, let's assign that to 4x. Okay, well, I could divide by x on both sides, and this is a common form that we've been talking about. And so I've got y all over x is equal to that constant of variation, which is a 4. So in this case, yes. All right, y times x is equal to 4. Again, let's just start again with our y is equal to 4x. Is there a way for me to get that x to be multiplying by that y on the other side? And the answer to that is no. And we're going to talk about problems like that in our next lesson. Y is equal to 4 all over x. Again, we're going to start with y is equal to 4x. Is there a way for me to get this x to go underneath, to have 4 all over x? And there's not. So, no. All right, and we're going to start with x is equal to 4. Let's see what that looks like on a graph. So if I had my coordinate grid, x would be going through at the 4. It would look like this. Is that going through the origin? So the answer to that one is no. There's one more that I'd like to look at that I should have had on here, and that would have been if I've got y all over 4 is equal to x. Well, let's take a look and start. Y is equal to 4x. Well, could have I divided by 4 on both sides and gotten that form? Oops. I'd have 4, or y all over 4 is equal to x. So in this case, this one right here that I just added here, this would be a yes. All right, so in this lesson, we took a look at how you can write direct variation equations.